Good afternoon, everyone. Thank you for taking time to join my doctoral thesis presentation. I am Tanjim Mahmud, a doctoral candidate at this university. I am going to present my doctoral thesis. My doctoral thesis title is Multilingual Cyberbullying Detection in Low-Resource Languages and Dialects. Sorry, sir, this Webex is disturbing. I don't. If I press this and Webex is coming. Or, Okay. Again, I started. Oh, problem is when I press this moving slide and the Webex is coming window. Yeah. Yeah. Now it's okay. Now I can.
Okay. So maybe start from here.
Good afternoon, everyone. Thank you for taking the time to join my doctoral thesis presentation. I am Tanjim Mahmud, a doctoral candidate at this university. I am going to present my doctoral thesis. My doctoral thesis title is Multilingual Cyberbullying Detection in Low-Resource Languages and Dialects. Here is the roadmap of my thesis presentation. And here I am presenting the key contribution of my research. Firstly, I reviewed all studies on the cyberbullying detection in low-resource languages and highlighting research gaps and proposing best practice for the future studies. And secondly, I created automatic vulgar word extraction method achieving near human performance. Thirdly, I created Bangla and Chittagonian cyberbullying data set and tested on the all machine learning and deep learning model. Finally, I propose transfer learning method based on the source target language similarity, achieving the similar performance to the training on the same languages. Let's begin with the background and the context of my research, where I will outline the challenges facing the multilingual NLP and why this work is crucial. The key topic in my research is the cyberbullying. Cyberbullying is that repeatedly harmful behavior using digital technologies to sharing abusive content impersonation. Moreover, cyberbullying refers to harassment, humiliation, and spreading rumor and discrimination. And the right side images show the reason for the cyberbullying. Why people cyberbullied is the personal appearance. 61% seems to be the most common reason for cyberbullying, followed by academic achievement, 25%. Consequently, cyberbullying can have the serious impact on the self-esteem and the mental health of the people who experience it. And at the right side images show that impact of cyberbullying. 41% of people who were cyberbullied developed social anxiety, and 37 of them developed depression, while 26 even had suicidal thought. In recent years, the rise of the social media and online communication has led to widespread cyberbullying, and also impacting user across the diverse linguistic background. Therefore, almost all developed countries has been facing this issue. Even developing country facing these issues a lot by using the following social media. Social media is one of the surveys shows that Instagram is the most common platform for the cyberbullying, closely followed by the Facebook and Snapchat. This slide indicates that shows that statistics of the Facebook user. Here we can see that most of the developing countries is the South Asian countries. India has the highest number of the Facebook user globally. India is a country to 120 languages with the native speaker according to the census of India. Since India, the right side tag shows that is that 12 Indian languages with the highest number of native speaker based on the census of the India. These languages are lack of substantial digital and research resources, and so that all of those languages is the low resource languages and dialect. Now, I'll show what is the low resource languages and dialect. Before low resource languages and dialect, I would like to express the what is the high resource language. Is the high resource language is that is the most of the developed countries exist and has a large amount of linguistic data. English, Japanese, Chinese, Spanish are the example of the high resource language. On the contrary, low resource languages and dialect, mostly languages of the developing country, a small number of available resources and level data, and many regional languages are the dialect, and Telugu, Assamese, Malayalam are the example of the low resource languages and dialect. This slide indicates is the one pyramid shape. Here is the pyramid shape. Here's one of the research shows that 20% of the world's 7,000 languages are studied in the most LP research, and this pyramid shape is the peak point is the high resource languages, high resource languages, and the middle portion one the medium resource languages where the few level data, and the medium sizes Wikipedia data. Most of the European languages like Polish, Slovenian, Croatian is the bottom portion is that low resource languages where the no level data. And this is a Bengali, Urdu, Tamil, Kannada, is Nepali is the example of low resource languages. This is the reason NLP solution by the language, and the right side is the low resource portion is the it's a 6%. 6% languages is the low resource languages. Currently, NLP solution majorly focus on this here. One of the few high resource languages like English and Chinese, and although there are 3 billion low resource language speaker mainly in the Asia and Africa, such a large portion of the world population is still unserved by the NLP system. So that during my research, I consider this as this yellow portion and like Asia and also African languages. Combating these issues, combating these issues is just challenging for this manual formation like internet patrol. There's a need the human doing by hand and requires too much time to effort and psychological burden. So that solution is the automatic cyberbullying detection. My research encompasses two primary questions. First, on how to address the challenges of cyberbullying in low resource languages and dialect with limited training data, and second one is the no available training data. And to deal this research question, I have to develop a driving cyberbullying detection tool to reduce the human effort, especially for the low resource languages and dialect. Then it's in this research, and first objective is the to deal this research question. First of that is a systematic review on the cyberbullying detection in low resource language dialect, and upcoming slide I will show the same everything. And the firstly, it's the during this research I conducted all reviewed all papers and covered 2017 to 2023, and I considered 23 low resource languages and dialect. And this bar diagram shows that is the red rectangle shape is that showing the how many papers actually produced in this year. And 2017 is not much, and then 2020 is a higher, was 16, and also 2021 60. And then this pie chart is showing this, and researcher is the previous researcher is the consider this the publishing venues as this, and also I consider this all of venues. And this bar diagram shows that is the increased number of the authors published in the years and contributing authors. And as you can see, the 2020 is the highest number of the contributor in this field. And this during this systematic survey, I considered these 23 low resource languages and dialect within the 10 language family. And this slide shows that is the tabulation formation of the systematic survey. After finishing systematic survey, I got the most prevalent issues. Is the first one is the very little work is done in the dialect of low resource languages, a small size data set, and unknown data sources, and limited experiments, superficial field survey. After that, I propose good practices for the cyberbullying detection. And the firstly is data collect extensively and maintain the balanced data set and collaboration with the expert and need to user taxonomies and guideline with example for the annotation and model start with simple and progress to advanced method, and continuously update this model based on the online languages, and evaluate the statistical methods, and also consider these ethical issues. And concluding remarks in this section, and I studied this studies all papers in this is that a systematic survey, and also one observation is saying cyberbullying is a growing importance in the NLP, and also I highlighted the research gaps and proposed best practices. And upon completing this study, I have published the following papers. And as the first attempt, I wanted to deal this mention research question. Is the first I conducted the automatic vulgar word extraction and detection, and they start with simple method. And is that this research is the main topic is the vulgar remarks. Vulgar remarks is the swearing taboo word, offensive language, and one research shows that is 30% people of the experience with this vulgar remarks. And I consider the Chittagonian dialect of the Bangla for where 30 to 60 million native speaker exist. And this is the example of social media comment, and also is the vulgar word remarks. And during this research, I faced this research challenges: no annotated corpora, lexicon, insufficient data preprocessing, and that I collected from the manually from the Facebook, and 2,500 post comment, and this is the 3 example of the from data set. And who was the data annotators? I considered 1 male and 2 female, and the native speaker of the Chittagonian dialect. Who developed the data annotation standard and guideline? 2 people in work in NGO, non-government organization, who deal with the internet-based harassment, and 1 male and 1 female, and both native speaker of Chittagonian dialect. And the data is the this slide indicate is the data annotation process. Is the data annotation I consider 3 annotators, and 3 annotators they got the training with the annotation standard and guideline, and they got sample and sample data, and then produce the labeling, and after that I compute the inter-annotator agreement. If inter-annotator agreement is bad, and they got the retaining, and if agreement is good, and finally produce the final label. And sometimes is the some sample is the got the conflict, and so conflict resolve this conflict through the annotator after discussion. And after that, and data annotation result 1009 vulgar sample and 1476 non-vulgar word, 15 conflict, and this one example of the conflict example. And to validate this data set, I employed the Cohen-Kappa score, and the Cohen-Kappa score, and I got this average agreement value is 0.91, indicating very strong agreement among annotators. And then I propose baseline method word extraction method, and I propose 3 baseline method: no additional filtering of non-vulgar word, and manual or human filtering of non-vulgar word, and additional automatic filtering of the non-vulgar word. And right side image shows that is the mechanism of the of vulgar keyword extraction method. And this is the top 10 most frequent vulgar word in the dataset. And then here the in this study's key finding of the research is the firstly is the blue color is showing that is the ratio of the vulgar word within the 10 to 100 word and then pink color is the no additional filtering of the non-vulgar word is that and red color is the no additional filtering of the non-vulgar word. Is the purple color is showing that automatic filtering of non-vulgar word. And is one observation thing is this finally we got this is the purple color score is the automatic filtering of non-vulgar word with got 0.70 is the and which means near close to near human level score. And that in this concluding remarks and these studies I achieved the near human accuracy score with 0.70 and consequently this therefore the keyword extraction method has one issue is the constant update the lexicon, and so that I had desired to extend the accuracy level, and after that I conducted ML based detection approach. And then ML based approach here firstly data preprocessing step is the this is the one sample raw text, and this is the firstly I removing the punctuation red and then removing the emoji and emoticon, and red color is removing, and removing the English character, red color is removing the English digit is red color is removing the stop word, and finally tokenize this text. And after that, I employed the feature extraction, and I consider the count vectorizer and a TF-IDF vectorizer. And after that, and I applied the various type of machine learning model. And this experimental result here, you can see that is the its logistic regression is the score is a 0.91 is outperformed than other machine learning model. And one observation thing, decision tree is the score is a SBM score is the lower than my proposed keyword based method. And then performance using TF-IDF base in the logistic regression outperformed than other model, and decision T is the lower than proposed key based method accuracy. And the concluding remarks in this study, in this I achieved this near human accuracy score of 0.70, and also I applied the machine learning based detection approach. And after completing this study, and I published this 2 papers in this several journals. And then, and after that, this third objective is the multilingual cyberbullying detection. And this I consider the 2 esteemed low resource languages, Bengali and Chittagonian dialect. Here the data sample example, and right side images show that how I collected data. And this is the dataset statistics, and the number of samples in the Bengali and Chittagonian is more than is 5,000 sample, and then data sources of dataset, and I collected the different types of social media platform here, and is the statistics of here showing. And then who was the data annotators, and also I considered the previous study native speaker and 2 female and 1 male with linguistic degree. And that after that data annotation process, and also in this study I applied this study for the same methodology outlined this previous research, and this table shows the summary of the data annotation and bullying non data is the we can see this most of the near almost is a balanced data set. And to validate this data set, and I employed this Cohen-Kappa method, and so to calculate the inter-rater reliability. And then we can see this both of these languages indicating near perfect agreement among annotators. And this is data preprocessing process, data preprocessing steps, and also similar to the previous studies, this and this. Sure. And after that, I employed this feature extraction to extract the feature. And for the machine learning model, I conducted TF-IDF vectorizer, and for deep learning model, what to back. After that, I employed classification algorithm is the different types of machine learning model, ensemble methods, and also neural network based method, hybrid network, transformer model. And this is the hybrid network model architecture. This is the BiLSTM Guru. Here we can see this, and we can take data and then BiLSTM layer, and also enhance this the linear sequential model, and after that dense layer to fully connected layer to predict the outcome. And similar to this same framework. And this experimental result here, this classic machine learning model for multilingual cyberbullying here, SBM is the outformer than other model here. And ensemble learning model is the ensemble boating is the outformer than other model with 0.72. And the deep learning for deep learning and CNN is the outformer than other deep learning model with 0.811 accuracy. Hybrid deep learning model and CNN plus LSTM with BiLSTM is outformer than other hybrid network is with 0.82 accuracy score. And after that, I conduct a transformer model. Is a transformer model XLM Robata is a outformer than other transformer model with 0.841. And concluding remarks in this studies, I created the two dataset, Bengali and Chittagonian dataset, and also I conducted different types of machine learning architecture, and I achieved the good performance. And during these studies, I published in the following papers. And the final objective in my research, transfer language selection for the cyberbullying detection to deal with the second research question, no training, available training data. And this limitation of the traditional method is the supervised cross-lingual method rely on the extended level data, not feasible for the low-resource language, and inadequate support for non-language specific cyberbullying detection. And after the in this research, I got the research challenges is the many low resource languages, a lack of level data, and difficulty to supervise training machine learning, supervise machine training, and then transferring learning between the language requires the addressing linguistic norms and contextual meaning. Effective transfer without additional training in the target languages is challenging. Problem solution is previous research showed that good result using the cross-lingual transfer for the abusive language detection, and transferring between the more similar language could yield the higher score. And the key in this research, and the key concept of my this research is the leverage this linguistic similarity to select transfer language. And my research key component is that first one is the linguistic similarity matrix to measure the linguistic similarity, and after that, and I employed a zero-shot cross-lingual framework. And this my research hypothesis is this performance of transfer learning correlated with the linguistic similarity between the source and target languages. To validate this hypothesis, use the multilingual transformer embed based experiment, and after that I quantifying the linguistic features is the linguistic land to back easy glot was, and to perform this linguistic closeness. And I consider two multilingual model, XLM Robata and multilingual BART embed ways, which is suitable for the cross-lingual framework, and which XLM Robata is 10 on the 100 languages, embed is 10 on the 104 languages. This is the images show that is the abstract view of the cross-lingual framework. And I consider this linguistic similarity metric EasyGloat. EasyGloat is that actually to calculate the similarity based on the lexical similarity, and linguistic to calculate the similarity based on the phonetic consonant. Lang to back is to calculate the similarity based on the different feature like a genetic, geographic, syntactic, inventory, phonological feature. And after that, I combine these genetic and all features and to calculate the average length to back. And linguistic similarity matrix is the keywords is based on the is one of database is based on phonological and semantic and grammatical knowledge of languages which exists that over the 200 different features and in total. And I quantification into the matrix selected all feature with the defined value of the age pair of language and calculate the similarity between the every language pair. And EasyGloat is the to calculate the similarity based on this share word. Like is here we can see that Bengali and Hindi languages is the common languages in this both of is the Sarkar is the and also Polish and is some example of this common word between these two languages. And this EasyGloat similarity matrix is we can see this one table is the diagonal one is the 100 means is the total overlap between the vocabularies. 0 means that there is no common word. This linguistic is the to calculate the similarity comparing the phonetic consonant. This is example of the Bengali consonant, and here also Hindi consonant is this, and right side images shows that is a Bengali and Hindi score is at 26.8. That means these languages are closely related. And then linguistic distance metric in similarly is the diagonal one. 0 means is the total overlap between the comparing phonetic consonant, and 0 means the no common phonetic consonant. And the length to back actually features the drift from the several features, the word attached linguistic structure and syntactic structure of the word language, and ethnologue and also foible. And the right side one table is the showing that is the 3 length to back distance score within the 3 low resource languages. Is the diagonal 0 means is the total overlapping between the languages, and other one not. This average to length to back distance matrix, this one the, and similarly diagonal one is the 0 means is the total overlap between the two languages, as 0 means not related. And the words matrix is exists the over 200 features based on the phonology and morphology, syntax and lexicon. And right side images show that is the Bengali and Hindi languages is the common phonology, morphology and syntax and lexicon over. And this keywords matrix is similarly diagonal one is the 0 means is the total overlap between the two languages, and 0 and other score is that is the no is linguistic no linguistic closeness. This I consider the data set is this 21 languages. In the 19 languages, the low resource languages and dialect, and one is the medium resource languages. Polish, English is the high resource languages within the 7 language family. And these the areas of the languages in these studies. And the data set statistics, you can say that here Gujarati is the small data set, but balanced data set is Malayalam is a large data set, imbalanced data set. Similarly, Vietnamese is a large data set, but imbalanced data set. This is the cross-lingual framework. Framework is the transfer learning framework is the first source languages, and I fine-tune the model with using the source languages, and after that prediction by the several target languages data. And after that, I amalgamate the linguistic similarity to check this the correlation between the our model and between the linguistic similarity metric. And experimental setup here I employed the two steps. The firstly select a model for the further experiment, and B is the secondly, and conduct zero-shot learning experiment. And so that to deal this setup, and I customize the dataset. Because of this, most of the dataset is the more than 2 class, so that I formatted in the 2 uniform format. And after fine-tune the 2 model, MBOT and XLM Robota base, and created 42 distinct fine-tuned model, and also total 441 individual experiment to assess the cross-lingual transformer performance. And this is the multilingual model selection. Is this we can see this XLM Robota and MBOT here, and MBOT score is across this proposed languages is the outperformer than XLM Robota base, so that MBOT I consider this for the to select the zero-shot experiment. This is the pictorial representation of the across the XLM Robota and MBOT. And this zero-shot experiment here, this across the 21 languages F1 score, and the vertical on the sources languages and horizontal targeted languages is the color is the similar same color is the similar language family. Here is the highlighted color showing that this actually is a notable observation of this zero-shot experiment. So and upcoming slide I will showing the what is the notable observation in this. This is the notable observation here. Firstly, notable observation: same family language perform better. Perform better is the like is the Assamese, Bengali, and Chittagonian, Nepali is the same languages. The red color is the same language families, and is the proposed sources languages and target languages. As you can see, that is the and when we consider the language same language family, and then score is much better to near to similar language pattern, and Bodo, but Bodo is the observation is think that Bodo is also much better. Because of this is Bodo is the Indian languages is a near state, so that is the interaction between the cultural and historical. And this similar language family perform better here is was average F1 score between the is the similar language family, and as you can see that is the much better than different language family is but Bodo is this also much better. Because of this it also Indian languages because due to the historical interaction and cultural interaction. And one observation is that is the Indonesian and Arabic Tunisian and Turkish is also much better score because of historical interaction. Because this Indonesian, Arabic, Tunisian, Turkish most common word uses this source languages, Indian languages. In this and second observation, linguistic similarity metric and transfer performance do not always maintain the same trend. In the QoS score, we can see that is score Marathi and Assamese and score is lower, but our model sources language is much better than linguistic metric QoS. And the notable observation: high linguistic similarity between source and target language does not always lead to the high transfer performance. Like as Chittagonian is a Bengali dialect, but score is lower. And then found more data languages improve the performance in the low resource languages. Just like Assamese language is a much better resources in the available online data. So that is, and also Nepali score is the highest score is the near to similar language, and that English and Polish generally perform the worst as a source languages, like a Polish and English languages. When I consider the Polish and English source languages, and all other Indo-European languages, Indo-Aryan languages is score is worse. And that's correlation with the after that correlation with the linguistic similarity metric is the I conducted 2 correlation method, Spearman and Pearson. Here F1 score and different types of various scenario of the correlation analysis I conducted, this, and this Pearson correlation coefficient score, here the method in linguistic language to bed Q was easy gloat, and we can say that when we consider this is with same source and target languages, and the Pearson correlation are role is a moderate and weak to moderate with all proposed similarity. Easy gloat similarity metric has the strongest correlation, and linguistic length to back Q was with the absolute correlation. And after removing these same source target languages pair and showing with no correlation at all, this the coefficient shows the band near 0 and losing a statistical significance. And likely Spearman correlation coefficient, and also here's a correlation or slightly lower being the weak to moderate with all of the metrics, and linguistic and Q was are weak to moderate. After removing this same source target languages pair, and then also losing the statistical significance. And in these studies and preparing this submission for the IEEE Transactional Effective Computing paper too, and conclusion and future work. And conclusion and cyberbullying, here in this research I conducted a systematic survey and all studies, and also I proposed this automatic vulgar word extraction method, and after that I conducted exhaustive study into machine learning model and deep learning model, and after that explore the task force language selection method for cyberbullying detection with using the zero-shot cross-lingual transform learning, and proposed linguistic similarity metric using WAS database with potential for the future refinement. And also once again I would like to express the key what is the key contribution of my research is the I reviewed all studies systematic survey, and also I highlighted the research gaps and proposed best practices, and also I conduct automatic vulgar word extraction method achieve the near human performance. And also I created two dataset, Bengali and Chittagonian cyberbullying dataset, also tested on the multiple model, and proposed transfer learning method based on the language similarity, achieving near similar performance to the same language training. And future work, and I'll have a plan to work with this 120 dataset across the different languages to develop the efficient system for the multilingual cyberbullying detection. Also moreover, I will have one intention to create a better similarity score metric for the low resource languages. Thank you for listening.